So the first thing I do is I take a look at these two denominators, and I want to find the least common denominator, so I'm going to factor the denominators. C minus d, of course, is itself. C squared minus d squared is the difference of two perfect squares, so it factors into c minus d times c plus d. Now my goal is to always do the same thing to the numerator of this large fraction as to the denominator. If you start doing different things, you get into some serious trouble, so don't do that. So I'm going to multiply the top by the least common denominator, and I'm going to multiply the bottom of this large fraction by the least common denominator. We can multiply the top and the bottom by the same thing without changing the value of the fraction. The goal in doing this is the least common denominator is the most convenient thing that can cancel this denominator and separately cancel this denominator. So I really like what happens in the lower part of this problem. These two cancel these two, and we just have c squared, and that's about as nice as it can be. In the numerator we have this situation, and so we have c times c plus d. Now one of these c's, this c, cancels one of these c's, and so we have c plus d over c. These guys don't cancel because you can't cancel part of a sum or a difference. You can either cancel this whole binomial factor or not cancel at all. This is the most basic way to do the problem. Now, at the risk of being confusing, I would like to show you a second way to do the problem, if I can organize my workspace here. This second way many people like, including teachers and students, but it only works when you have a single fraction divided by a single fraction. And that is that you can take the top fraction and you can divide it by the bottom fraction. Because this division bar can be thought of, this fraction bar can be thought of as division, and so what happens is you get multiplying by the reciprocal going on, because that's how you divide fractions. And now the way you simplify this is, of course, you factor. And while there's a lot of the same work here, these steps seem cleaner. Now this is appropriate when there's a single fraction here and a single fraction here. If you've got the sum of two fractions or the difference of two fractions, this method is really not very good. So now these cancel, this one cancels one of these, and we have our c plus d over c. You get to choose which method you like best. I think they're both pretty darn good.